So solution concentrations. I will hand your labs back in a moment. I'll leave it right there. Solution concentrations. In terms of chemistry, it's very important for us to know exactly how concentrated a solution is. And that's because that concentration is a representation of how much solute is dissolved in the solvent. In most cases, it's water. There are multiple ways in which we can represent concentration. The method I want to show you today is something called percent concentration. So the first one I want to show you is something called percent concentration. And then at the very end, I'm going to talk about something called parts per, which an example of a parts per concentration is parts per million or parts per billion. You've probably heard those terms before. I'm just going to be defining them for you. Are you heading up? Perfect. Thanks. And then tomorrow we will talk about a concentration method that uses the mole. So today we're not really going to be even talking about the mole. Maybe an example at the very end, we might bring in a little mole calculation. So all concentration calculations, whether it's a percentage calculation or one involving the mole or whatever unit, will always have the property of the quantity of the solute divided by the quantity of the solution. So again, like I said, all concentration calculations, and so this is almost like a general concentration equation. This is not a version of an equation that we'll actually be using in any way, because I will be showing you specific examples, various numbers for quantity, right? Quantity can be measured in many different ways. Same with the quantity of the solution. The important part here is that it is the solute, the thing that's being dissolved, divided by the total of the solution, not the solvent. So we're not really worried about the solvent in the end. In the end, we want to know what's that total amount of the solution. So it's the solute over the total solution. We use terms like dilute and concentrated to represent qualitatively, not quantitatively, but qualitatively, how much solute there is. And so if there's a small amount of solute in a certain amount of solution, we say it's dilute. And if you've got a large amount in a certain amount of solution, then we say it is concentrated, right? If you ever make, Kool-Aid, or I don't know if anybody drinks Kool-Aid anymore, but if you ever make Kool-Aid and you put a lot of water in it, it's like watery. That's a dilute solution. It's a dilute situation, all right? Okay, so let's talk today about quantitative concentrations. And the first type of concentrations I'm going to be teaching you about are what we call percentage concentrations. And we have seen percentages before. We've seen percent composition. That was a percentages of masses. We've seen percent yield, also a percentage of masses. And remember, in every example where we use that percentage, it's what we want to study. Like if you get a test, you get 8 out of 10. What you got right, what we're looking at, divided by the total times 100. And that's the exact same for a percentage concentration. The volume of the solute, that's the thing we're interested in, over the volume of the solution, that's the total, times 100. Now in this specific situation, we're looking at something called percentage volume by volume, and we use it when a liquid is dissolved in a liquid. Just kind of looking ahead, the next one we will do is percentage weight by volume when a solid is dissolved in a liquid. And the last one will be percentage weight by weight when a solid is dissolved in a solid. Examples of substances that are measured with a volume by volume. Well, vinegar is an example. It has acetic acid in it, and in vinegar, you have 5% of that solution is pure acetic acid. Other examples of liquids that would say percent V/V, and I don't know if you've ever looked at a vinegar container, but in the corner it'll say 5% by volume. By volume means V/V. If you've ever purchased hydrogen peroxide, right? Maybe you're purchasing for a first aid kit, you get a cut, you clean it with hydrogen peroxide. I don't know if anybody does that anymore. Typical hydrogen peroxide you get at the drugstore is 3% hydrogen peroxide. All right? You can get stronger hydrogen peroxide. My uncle runs a dairy farm, and they have 30% hydrogen peroxide that they use to clean the piping that moves the milk from the milking machines to the to the milk parlor, to where they keep the bulk storage tank or whatever. So you can get different concentrations of those things. All right? Alcohol is measured by V/V. So on that can of beer, it says 5%. It's 5% ethanol, in that container. Okay? So let's think about what these numbers represent, because we're going to be doing some calculations with them in a moment. Now, number one, if I ask you to calculate the percentage concentration, it's pretty easy. You're going to just put the numbers in the equation and get a percentage. But if I want you to calculate, say, the volume of the solute or the volume of the solution, you have to rearrange the equation, or we can make an easy conversion factor out of every percentage. In this particular notation, 5% V/V, it tells us everything we need to make a conversion factor out of a number like that. 5, all right? And what does percent really mean? Sorry? Not times 100. Nope. Percent. All you French immersion people, yep. For each 100, or per 100. So 5% means 5 per 100. Now the V/V tells us what goes with these units. 5V milliliters. And because it's over V, the bottom one gets milliliters as well. And by the way it's described, we have 5 milliliters of acetic acid per 100 milliliters of the solution. what do we call a solution that is 5% acetic acid? What's the brand thing called? Yep, vinegar. So 5 milliliters of vinegar, and you have to say Vinegar or you will spell it incorrectly every time. And Vinegar, you won't spell it incorrectly. So that's a conversion factor. If I want to know, how many milliliters of pure acetic acid is in 350 milliliters of vinegar, I can use that as a conversion factor, or I can flip it over. And that's a lot easier than having to memorize a formula and figuring out how to rearrange the equation. So like I said, 5 per 100 milliliters of acetic acid in vinegar. We just need to create that conversion factor. Let's do some examples. So in this example, I've been given the number of milliliters of pure acetic acid in 500 milliliter bottle of the solution. It looked like it could be a type of vinegar. It may not be 5%, but let's calculate the percentage. So this one is pretty straightforward. I've got 140 milliliters of pure acetic acid in 500 milliliters of solution. So let's get that concentration. And I don't normally write this equation out because it's just a percentage, but I'll write it out just to show you where it's coming from. Volume, in this case, in milliliters, so volume of, in this case, it's acetic acid over volume of solution times 100, and you don't need to write that all out. 140 milliliters, 500 milliliters times 100. What's the strength of this particular solution? Yep, 28%. 28% V/V, because we used volumes in there. Pretty straightforward. Calculate a percent. Let's now try to calculate some of the other values. Are we good to go? No, we're not good to go. We are good to go. Yes, we are. All right. Example 2. What volume of a 3% V/V solution would contain 45 milliliters of the solute? Now notice in this case, we're not even telling you what kind of what the solution is, whether it's acetic acid or hydrogen peroxide or alcohol. But it doesn't matter. The way I would attack a question like this is I would turn that 3% V/V into a conversion factor, knowing that I can flip it over depending on what I want to find. So could somebody help me out and tell me what that 3% V/V is going to look like in a conversion factor? I'm going to have my line. I need to know what's going to go on the top and what's going to go on the bottom. And it's all in all of these little symbols. Every little symbol in there tells me a little bit about the conversion factor. Atlee? 3 milliliters, sorry? Yeah, solute. Whatever that substance is, we don't really care. Excellent. And what's going on the bottom? Atlee, you got it? Yeah, 100 milliliters of solution. %3 V/V, milliliters of solute over milliliters of solution. Now let's do our conversion factors. I have the number given, 45 milliliters of the solute. So the number I'm given is 45 milliliters of the solute, and the question is, what volume of that solution would contain that. So, just like we know with any conversion factors, if I've got milliliters of solute, what has to go on the bottom? So I can get rid of it. Dallas? The 3 milliliters of solute. 3 milliliters solute. 100 milliliters solution. Milliliters of solute cancels out. I'm left with milliliters of solution, which is what I wanted. Now, on the bottle, it might just say 3%. It might not say 3.0%. We should be rounding to one significant digit, but let's keep 2 significant digits here. I know I'm breaking my rounding rules just because one significant digit is going to get us a funny type thing. What do we got for 2 significant digits? Or just tell me what's on your calculator and we'll do some rounding practice. What do you got? 1,500? That is the 2 significant digits. That's good. 2 significant digits right there. Milliliters of solution. All right? 2 significant digits, you could also express it as 1.5 times 10 to the, what would it be? 10 to the 3 milliliters. All right? If you're given a percentage, turn it into a conversion factor using all the things, and then just use it to find whatever you need to find. If you got to flip it, you got to flip it. Okay. Solids dissolved in liquids. Percent mass. Percent weight by volume. Yep. So W/V. We say weight. Technically, weight is a force. If you've taken physics and you've talked about the force of gravity with Mr. Petras, you would have talked about weight versus mass. In chemistry, we're not quite so picky. So when we say percent weight, we really mean the number of grams, even though that's technically a mass. And again, by volume. Oh, I should maybe express, it doesn't have to be milliliters and milliliters. It could be liters and liters, right? So if you had 3%, it could be 3 liters in 100 liters. In terms of this one, grams and milliliters go together. It means you'd have kilograms and liters going together. That's kind of a tricky one because you'd multiply everything by 1,000. We'll just stick to grams and milliliters for this one. But you could have everything multiplied by 1,000 and have then kilograms and liters. So now it's a mass of solute over volume. Again, when you're finished this statement about the 4% potassium chloride, go ahead and try to write the conversion factor. All of the information is in here. This time the W tells you to write grams instead of milliliters. If you're not sure, get a pencil out. %4% W/V potassium chloride solution. What am I putting on the top? The Monday morning pause. Chelsea, what do you got? I could have put a formula there. It would have been a lot easier. Correct. 4 grams potassium chloride, and what's on the bottom? Yeah, Janessa? 100 milliliters of the solution. Okay? And then we can use that conversion factor to do whatever we want to do. Okay? Let's do a couple of examples. There is a trend to my examples. First, I make you find the percentage, and then we're going to find something else in the second example. And I'm hoping as you're thinking about this and thinking about the percentage, you're saying to yourself, wow, this is really pretty simple stuff. We're just finding a percentage. And if that's what you're thinking, that's excellent. It is pretty simple stuff. I'm not even going to write down the overall equation that we wrote on the previous slide. We're looking for a percentage. Normally I don't put that, I usually just put C, but percentage C is fine. It doesn't matter. There's the solute, sodium hydroxide, 7.5 grams per 250 milliliters times 100. What do we got? We got 3%? Is it exactly 3%? 3, and we could go to two significant digits on this one. 3.0% W/V. The W/V is telling the person who wants to use that percentage as a conversion factor what units that you used in calculating it. So it is important. It's part of the unit. Nothing earth-shattering there. So again, in this case, we were given the percentage, and eventually we're going to want to figure out what is it, the amount of juice that's being consumed in order to get the 9.0 grams of sugar. And again, first we've got to write this down as a conversion factor. If someone could tell me what that conversion factor is. Vanessa's thinking about answering there. Do you have it written down yet? Oh. Thought maybe you already written down. That would be great if you did. We're using each of the symbols in our percentage there to tell us what goes where. What goes on the top of this thing? Vanessa. 8 grams of what? Yeah. Stugar. Got to say it like that or you spell it wrong. Yep. Over 100 milliliters of juice. Because if you don't say it like that, you spell it wrong. English sounds a lot different in my head when I write things down. That's correct. That's excellent. So, again, we start with what we have. This person wants to consume only 9 grams of the sugar. Notice I was saying it in my mind as I was spelling it. And just use it as a conversion factor. I hope we understand Yeah, what are we doing here? Yeah, 100 milliliters. Yeah. Again, 8%, that's typically the way it would be presented on a package. One significant digit. It probably is two significant digits. I would hope they're not, being off by plus or minus a half. We'll keep two significant digits here once we get it. Somebody got a number? What do you got? So 112.5 milliliters, right? Milliliters. And what's that going to be to two significant digits? Yeah, Janessa? 110 milliliters. Or 1.1 times 10 to the 2 milliliters, right? If you're not sure, your calculator would turn into scientific notation, then it becomes really easy to determine the significant digits. 1.1 times 10 to the 2 milliliters. Yep. If I were to write this in terms of scientific notation, it would go over 1, 2. I would then write this as 1.125 times 10 to the 2 milliliters. And then as I see this, I only need to keep the first two, and that becomes 1.1 times 10 to the 2, which then, if you wanted to put it back in regular notation, becomes 110. Percent mass by mass. Now, we briefly talked a little bit about solid state solutions the last day, things like alloys. But it turns out that for some reason well, I don't know whether it's the milk producers or the milk marketers, milk fat tends to be expressed as a W/W. So if you have 2% milk, that's 2 grams of milk fat in 100 grams of the milk. And I don't know why they've chosen that particular convention. But as long as it states it on there, we know that we can deal with it. Other places where I've seen percentages in W/W, take a look at a toothpaste tube sometime. You'll see all kinds of various things. If there's fluoride in the toothpaste, it's not as simple as sodium fluoride, but it'll have a fluoride-containing compound, and it'll express it as a percentage. It's a very small percentage. It's usually something like 0.352 or something like that, a very tiny percentage. But you'll see that expressed on the toothpaste tube like that. I'm also finding that if you look at antibacterial soaps, there's a chemical in there, and the reason I'm aware of this is because my wife is allergic to this chemical. It's called triclosan, and it is an antibacterial agent, and it'll also be represented as a little percentage, and I think they use W/W for that as well, even though it's in a liquid, but I guess the soap is like not necessarily a pure liquid. It's almost, gelatinous. Anyway, that's another place you can see. If you take a look closely at products, you'll notice percentages all over the place. All right? Okay, so if we've got 2% W/W milk fat, what's my conversion factor going to look like? I'm hoping we're starting to see the trend. The W's are going to tell you what units. Yep. Yeah, milk fat. Very good. It's the milk fat. And it's going to be per 100. This is a W/W, so grams of milk itself. Excellent. Yep. The milk is the solution. The milk fat is the thing that's in there. All right? Let's do a couple of calculations as we have been. Again, I'm hoping you're noticing a trend here. We're going to calculate a percentage, and then we're going to generate a conversion factor and practice with it. A sterling silver ring has a mass of 12 grams. That's the entire ring. It contains 11.1% of pure silver. Determine the percentage concentration of this ring. So again, percentage concentration. This one is going to be W/W, but we understand that. Pure silver, 11.1 grams, 12.0 grams for the entire ring. Now you might say, if 11 grams of the ring is silver, then it's probably the thing that's doing the dissolving. You might think of the silver as being the solvent. But when doing percentages, we're not really concerned about what the solvent is. You'll notice the solvent doesn't come into play anywhere in our equation. So we can represent even that largest component of the solution, which we call the solvent, we can still think of it as it in a percentage. And that's what we're doing here. 11 grams of the pure silver. So then, therefore, what percentage of the ring is pure silver? So we can do that calculation. Do we have a number here? Haley, what do you got? 92.5%, 3 significant digits is good. So even though technically the silver might be doing the dissolving in terms of our definitions, we can still come up with a percentage of how much that is. And here's an example I created. It's not 2.5% sodium fluoride in toothpaste, by the way. That would probably be dangerous. Like I said, I think it's something like 0.03 something. Last time I checked the toothpaste. I look at those things. It's weird. It's just what these weird chemists do. Oh, wow, look at that. It's cool. So, just as we have been doing, what's my conversion factor going to be? All that information comes from that description at the top. Yep, Chelsea, what do you got? Of what? Nope. No. What's the entire solution called in this case? Toothpaste. Oh man, paste? Really? I'm going to struggle over paste? I am. .2 gram sample of toothpaste. Well, I want to figure out how much sodium fluoride is in that 1.2 gram sample of toothpaste. I can use it exactly the way it is. And it's looking like 2 significant digits. Because the 100 here, by the way, in our percent is exactly 100. That's the definition of percent. It's exactly 100. So 2 significant digits here. Yep. 3.0, that's not a percent. I think we got grams, don't we? Right? Yeah, so 3.0 grams. And that would be of NaF. No good? Yeah. Why did you times it by 100? I understand. 0.03? 0.030 grams? NaF. I guess the percentage examples you were doing, you were multiplying by 100. So you took that small number and you multiplied it by 100, which you don't need to do here. Okay. Now, at this point, I often go on and talk about this parts per million or parts per, but I'm going to let you work for a little bit, and then I'll worry about the parts per. I'm trying to do it at the end of class. We'll see. Now, we've got those textbook questions, but I also have a little sheet that has some extra problems on it as well. Question? Oh, it's asking the moles at the end as well? Oh, that's exciting. Yeah, we'll do that in a second. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4. 1, 2. You're welcome. Well, just to kind of keep us, thinking about moles, how am I going to figure out the number of moles of sodium fluoride in 0.030 grams of sodium fluoride? What do I need? I need the molar mass. Yeah, that's exciting. So essentially, that little add-on is going to kind of get us thinking about tomorrow. We will still need to keep in mind the molar mass and being able to convert things from mass to moles. I don't know what fluorine is. What is sodium? 23? 23.0. 19.0? Yep, 19.0. And what did we say, 42? We could have just kept going with the conversion factor, but that's okay. 0.030 grams, 42.01 mole. And what do we get? Yep, Alice. 0.0007. Do we need one more digit on the back end? 71 moles NaF. Okay?